Hello everyone, this is Peter from Learnwithuncletee, and in this tutorial, we are going to be starting the introduction to integral calculus. Integral calculus. Now, basically, the first thing that you need to know about integral calculus is that it is basically the opposite of differential calculus. This has been discussed in the first introductory video that we have on calculus, where we use BODMAS to represent both differential calculus and integral calculus. So now, since differential calculus goes with what we call derivative, integral calculus goes with what we call antiderivative. So basically, we can just represent these as antiderivative. So if you recall, for example, let's say we have an explicit function. Let's say y is equal to x raised to the power of n. We know that the y dx is basically going to give us nx raised to the power of n minus 1. So the antiderivative of these is going to give you what you differentiated back. So now let's take a look at this. Firstly, we can look at the integral calculus as a continuous sum, which is a form of accumulation. So what it means is that, let's say you consider the word sum, let's say SUM, that's what we call sum. The first letter here is S. If we elongate it, this is what becomes your integral, which is what we have here, integral calculus. So if we are to integrate nx raised by n minus 1, let's put it nx raised to the power of n minus 1. With respect to x, this is dx. Now, recall, integral calculus makes use, or let me say basic integral calculus makes use of the AD method. AD method. And what does the AD method simply means? You add 1 to the power, you divide by that new power. So the power here is n minus 1. If you are to integrate this, you add 1 to the power. So that will be nx raised to the power of n minus 1 plus 1. Then you're dividing by that new power. N minus 1 plus 1 is going to give us n. Now, because this is an indefinite integral, because one thing you need to understand is that we have two types of integral. We have what we call a definite integral, and we also have what we call an indefinite integral. Indefinite integral. So the representation of a definite integral is when you have your lower and your upper boundary. So for example, if you have integral x raised to the power of 2 and is having a lower boundary of 1 and it has an upper boundary of 2. So it means that you are finding the definite sum. That is because the integral also is a kind of area under a curve. So basically here, this gives you a definite answer. You are going to get the definite answer when you evaluate this integral. But for an indefinite integral, you're not going to have a lower boundary. You're not going to have an upper boundary. When they just give you integral x raised to the power of 2 dx. So don't forget, this also is with respect to x, which is dx. So you discover that in this form, there is no lower boundary, there's no upper boundary. So when you integrate integral functions like this, you have to put an arbitrary constant c because there's no definite boundary and you don't know the definite answer to that question. So for example, if you solve these using the same approach, it's from these that we actually dived into this. Let's just know that this is an indefinite integral and there has to be an arbitrary constant c. So we'll just put plus c. So n will cancel n, minus 1 plus 1, that is 0. So we are left with x raised by n. That will be x raised to the power of n plus c. So same thing here. If we integrate x squared, you add 1 to the power, you divide by that new power. This will be x raised to the power of 2 plus 1, which is 3, divided by 3. Now, because it's an indefinite integral, you have an arbitrary constant c. So, but for this, integral of x squared, because if you integrate x squared, you still x squared over 3 over 3. So we write that x raised to power 3 divided by 3. So now, because you have a lower and an upper boundary, then you are going to have something like this. So you have your lower boundary here, you have your upper boundary here. So some representations can just use this single line and you still have your lower and upper boundary. So, but what it basically means is that you substitute your upper boundary into the function that you have here. You then subtract it from when you substitute your lower boundary into that same function. So this basically is going to give us 2 raised to the power of 3 over 3, which is 8 divided by 3, minus when you substitute 1 raised to the power 3 divided by 3, which is 1 over 3. So your final answer here is actually going to give you 7 over 3 square units. 7 over 3 square units. So basically, that's more like an introduction to integral calculus. We are going to treat different rules under the integral calculus. We'll treat different methods. We're also going to treat integration, or let me say some of the methods, for example, integration by substitution, integration by trigonometry substitution, integration by parts. We're also going to need application of some very basic topics like partial fractions, for example. You actually need to understand partial fractions when you're dealing with some integral questions. It's actually going to be of help. So as we dive into the tutorial, you're going to understand very much and more so that when we enter application of integral calculus also, you are going to understand properly. So on these notes, this is a basic introduction to integral calculus. And in the next tutorial, we're going to start fully with integral calculus. Once again, this is Peter from Learnwithuncletee. And if you have not subscribed to this channel, do this. It will help more people to find this video. Thank you very much. See you in the next tutorial.